Yes, it is. So just another minute and then we are going to kick off. And we are glad to see in the room, we have Michael. I'm very glad you are here, Michael.
Hi,
Great to have you.
my camera made it. I'm also with Masadik, who's one of the other educators at Blockchain Sensei.
Hi guys,
Cool.
pleasure to be here. Thank you for the
Excellent.
invite, Alison.
No worries. Welcome. We'll introduce you both fully. It's just a bit of this is for previous sessions that we've had. So if you want to go check those out, follow the link and follow our YouTube, and you will be able to see us in full action in previous sessions. And big thank you to all those who are constantly supporting us. And then we're going to end our welcome to everybody with, here we go. So remember everyone, get up your cameras, link over to and join us on all of our socials. Please do feel free to do that. And with that, I am going to stop sharing. I'm also going to turn the music off. Hopefully that's ended. Welcome, everyone. I'm really pleased to have everyone in the room with us today. As everyone knows, this is our 5th Academy session, and we do these every month before our In Real Life event, which is next Monday for those in London wanting to join. And each time we've been following the topic of the In Real Life event, and today the topic is the basics of the blockchain, layer 1 and layer 2, and we're going to get more into that. But this is really stemming from, we've had conversations about Bitcoin, we've had opportunities to talk about investments, and we really feel that it would be great to actually make sure that we all feel really solid about the blockchain, especially now more and more everyone's talking layer 1, layer 2. And so we wanted to really have this session. So today is all about the blockchain. And we hope that at the end of it, you will feel much more knowledgeable about what the heck blockchain is, terms, layer 1, layer 2, how they interrelate, and some real life examples. So that's our plan for today. But before we get into all of that great stuff, I do want to invite Caitlin up to the screen to say hello to everyone and to give us a welcome formally from Crypto Mondays London. So over to you, Caitlin.
Thank you, Alison. Hi, everybody. Welcome to, I think this is our our fifth Academy session. So thank you so much, Alison. You've been a brilliant host. So Crypto Mondays Academy is an offshoot from Crypto Mondays London. Crypto Mondays London being a IRL monthly meetup that we've been running since 2018. That's sort of dedicated to providing an all-access space for anyone who's interested in learning anything about Web3. So we generally tend to have panels or fireside chats alongside networking opportunities. And we have been working for the last several months with Michael Harding and Blockchain Sensei to sort of combine forces, because the way we see it, the more accessible and the more people that we can onboard, the better it is. The better our industry is, the better informed everybody is. So Academy sort of was born of this idea. We got some feedback from the community saying that a fair few times our topics have been a bit advanced. So the idea was to offer an online sort of 101 foundational session about the topics that we're talking about in real life. So our audiences tend to be a little bit like intermediate. So the Academy is just to welcome anyone who's brand new to the space. So I'm super excited to learn all about our blockchain layers, our topic today, from Michael and Blockchain Sensei. And a big thank you as well to Wasim from Vault 12, our sponsor. So I shall say no more, but for those of you in London, I do look forward to seeing you at the event in real life next Monday. If you can make it, Michael will also be there. Thanks, guys.
Thank you. And thank you, Caitlin, for doing my job of the next bit, which is to say a very big welcome to our team. Massive thank you for being that dedicated sponsor of us. To be able to make this possible. So I absolutely appreciate that, as does the whole of Crypto Monday London. And everyone who's been coming to the event so far are lucky to be able to have the event because of your sponsorship. So thank you very much for that. And on that, I'm going to invite you to just take the stage for a moment and share.
Great. Thank you so much. I mean, when I knew about Crypto Mondays, I've been going to the New York one for many, many years, right from the beginning. But I think when I heard about the Academy, it was just a no-brainer to sort of feel like we wanted to put some energy and some effort into supporting that. And you guys have done through the year now, putting this on and putting it on right ahead of the actual in-person meetings. So I'm actually very excited that I'm actually going to be there next week. So hopefully I will meet you all in person. So just 2 seconds on Vault 12. So Vault 12, we help you protect your cryptocurrency by helping you back it up and set it up for inheritance. So these are things that you are responsible for. No one's going to do it for you. You got to have a plan, but you also have to have a way to actually literally communicate all of the details of your crypto onto the person that's going to go be able to access it if you're incapacitated, passed on. So that's what we do. And hopefully I can talk to you all about it next week when I see you.
Absolutely. So everyone, please come armed next week. So there's 2 invitations there. One to talk to Wazim about everything, and then also Michael will be there, who obviously we've to bring up yet. But I think, I mean, I always, and I said it last time, and I will say it again because we have some new people in the room. I think it's really important, Vault 12, especially for myself. I particularly think about this. I happen to be visiting with my daughter today, and my daughter isn't quite as au fait with my crypto as I am, and it's really important for her to have that ability to access, to protect it. And so I'm absolutely really appreciate the work of Vault 12 to make that possible. So thank you. Really big thank you.
Thanks.
And with that, so we started the beginning by saying today it's all about blockchain, and I think for me it's the underlying principle of what we talk about in Web3 all the time. And whether we're talking about crypto, whether we're talking about NFTs, whether we're talking about investments, AI, everything is all based on blockchain. And that is at the heart of it. And the whole concept for me around blockchain, decentralization, which I know is a word that people might be going, what does that mean? And I know Michael's going to talk about that. So this is for me at the heart of everything. The blockchain enables us to do things differently, whether as an individual or as a company, or as a community, or as a state. And for me, that's why this is so important. So I'm really pleased that we're talking about blockchain today. And with that, I am going to invite Michael up onto the stage to say hello.
Hi, everybody. Thank you for having me. It's an absolute honor to be speaking with you all today and educating you on what I believe is one of the most important things to understand in the blockchain space, whether that's from an investment point of view, a development point of view, a marketing point of view. This is possibly one of the most important bits. So we're going to do everything we can to keep this as simple as possible to help you actually understand this area. So ultimately, again, please keep all questions to the end. But if you've got anything that you're at any point, if you're confused at all, just put a question mark in the chat, and then we'll use better metaphors to explain. So yeah, a little bit about myself. My name is Michael Harding. I'm the CEO of Blockchain Sensei. We've been around for the last 5 years, doing blockchain education for pretty much everyone under the sun, from Paramount to Manchester United Foundation to Crystal Palace, and universities like Cambridge and Oxford, just educating people on what blockchain actually is, how it can apply to their lives, how they can apply it to their businesses. And that's how I was fortunate enough to meet Masadik. And Masadik, if you want to just say a little bit about yourself.
Thank you a lot, Michael. Yep, so hi guys, I'm Musaddiq Ahmed, a writer and researcher, very involved in the crypto space. I've written for publications like City AM, and I work closely with Blockchain Sensei and Michael.
Cool, perfect. So let's get into it. If you want to share the slides that we've got for everybody. We are possibly going to be giving these slides away, possibly to one person, maybe. And then maybe that one person can then mint them as an NFT and do what they want with them. I've just got to check with my team to make sure that I can actually do that. But yeah, let's go on to the first slide. Cool. So ultimately, what is blockchain? So the methodology and metaphor that we use at Blockchain Sensei is think of the word block as computer and think of the word chain as link. It's basically data that's on different computers that is linked together. And this is the most important bit. The blockchain is what links the data from one computer to another. The data could be different types of data, and it can be done from different types of computers. My favorite way of explaining this is explaining the importance of shared data. So what is the kind of shared data that we're very common and used to using, and that's what we hold dear to us? Most of us here, I believe, well, put a Y in the chat if you use Google Drive. Put a Y in the chat if you use iCloud. Put a Y in the chat if you use any of the, or Dropbox or anything like this. Now, if these platforms were to disappear because all of that data that you've saved on those platforms is on their servers. So if their servers get damaged, normally they've only got one or two servers, or there's an earthquake, there's a fire, anything like that, a hack, that's all of your data vulnerable or potentially lost. Whereas if it's on a blockchain and it's split across multiple computers in a shared online database, it's now much more easier to recover that data and keep that data safe. So that's the quick way of explaining it. So Musaddiq, if you want to go into a little bit more detail.
I think the other thing, it's exactly as Michael was saying, right? You've got these computers, but you have the same computer distributed across, and this is the decentralized bit. Everybody is holding the same data. All the different computers that are on the blockchain are holding the same data. And it might be worth taking a step back and trying to understand what is a computer, right? So a computer, it just holds data, and that data can change in certain ways depending on the type of computer you have. So if we go back to maybe a Game Boy, if some of us remember the Game Boy, the Game Boy was just a computer. It was a computer that was limited by the data it had, and that data was the cartridges that we put inside it, and then the changes that that Game Boy could go through were controlled by the buttons on the Game Boy device. So in modern computers, we have hard drives that hold a lot of different types of data, and the transitions that data can go through are much more elaborate. Blockchains are a specific type of computer, and depending on the blockchain, it has different data sets that it can hold, and those data sets can go through different transitions depending on each particular blockchain. Now, the key is a blockchain is made up of lots of computers that all hold the same information and are all linked together using cryptography, which is where crypto comes from. And this is that link, which is the word chain, and this is where we get into explaining that link. It really gets to the crux of explaining blockchain itself.
Yep, cool. So what we're going to do is just going to quickly explain the process of how most blockchains work. So this is how this is the original way of how blockchains work. Not all blockchains work in this way anymore because there's been loads of technological advancements. So think of it as somebody wants to communicate something or make a change or send a transaction that is now broadcast to every computer that is connected to that digital computer, which is the blockchain, the virtual computer, whatever you want to describe it as. And then from there, that information is then added to all of those computers. So added to the block. So let's say, for example, I have a file, a Word document. I send a request to the blockchain saying, I want to upload this file. Every computer on the blockchain is then notified that Michael wants to send this file. I send the file, and then a piece of that file is then connected to every computer on the chain. And then anybody at any point can go and see that file and can see the date, the time that I requested and uploaded the file. And that's pretty much the simple way. Sadiq, if you want to go into a little bit more detail.
Yeah. So I guess, again, when we think about the word transaction, right? A transaction might be, I want to send money to somebody. It might also be, in the crypto world at least, it might be that I want to lend money to somebody, or I want to mint an NFT, as Michael was saying earlier. The transactions are not just, sending money as we usually think of transactions, but it's actually making any changes to the data that we have. So that's what a transaction is. So requesting that change be made, and requesting that it be made on the blockchain. And when it's made on the blockchain, for us to put it on the blockchain and for it to be accepted by all of the computers, for it to be accepted by all of the different computers, what the computers will do is that they'll validate that transaction, or they'll validate that what you're trying to do, you're allowed to do it. And each of the computers, they hold a set of rules. So they'll check your transaction against those rules to make sure that you're allowed to do that. And then if you're allowed to do it, they'll add that transaction to the blockchain. What's very special about the blockchain is it's all one way. So once it takes a lot of effort, it takes a lot of computation, we call it, to add transactions. But once the transactions are added, everybody can check that those transactions are valid very quickly. All the wallets, all the different applications, all the exchanges, they can check the content of the blockchain very quickly, instantly. And the way that all of this works, it uses a lot of complex cryptography. It uses things like one-way hash functions, consensus algorithms, public-private key cryptography that makes all of this work. And without going into all of that, I mean, if you guys want to explore some of these terms, we can definitely talk about it during Crypto Monday. You can look it up in your own time. It's very, very interesting. But it's worth remembering that this works. Blockchains have been around for about 12 years now, a bit more. And in that time, they've handled trillions of dollars worth of value, and the blockchain itself has never been hacked. And any computer scientist that you speak to, the technical, the maths guys, they absolutely love this stuff. And because they love it so much and they're the most loud people in it, it's sometimes hard to keep up with how it's actually working, but it is working. And any of the areas we want to delve into more, please leave it in the questions and we can come to it later.
Cool, brilliant. So let's go to the next slide. So ultimately, blockchains are ledgers. And what's a ledger? It's a big book. So like we said, the blockchains, what they're doing is they're storing any transactions. They're storing any requests to make any transactions. They're storing the time that someone requested to make a transaction. So imagine a giant book that every time you got on a bus, it took note of this is the day and the time that this person got on this bus. That's pretty much what it is. And that is a ledger. And these are digital ledgers. But instead of this book being owned and this database being owned by one person, it's spread amongst multiple people. So anybody can see, oh, what day, what time did Michael get on this bus? How much did he pay? Where did he travel to? That is what it allows you to do. So if you want to expand a little bit on that, Masadik?
I think the fact that it's a digital ledger is something that's really important when you think about the significance of cryptocurrency, because ledgers have been around for a long time as a financial record keeping system, or for keeping track of things, right? For keeping track of who owns what or who's done what. Now, the ledgers were first popularized by the Medici family about 600 years ago. And when they came out with ledgers and started using them in finance, they revolutionized the way that we did trade and commerce. And blockchain's first innovation through Bitcoin was taking that ledger and decentralizing it. As Michael said, putting us the same ledger on all of the different computers that come onto the blockchain, so that the ledger is shared and multiple people can see it and access it in real time and rely on the information held inside the ledger because it's across lots of different computers instead of being owned by a single person. And what we say is what is accepted is that Bitcoin is the first innovation of ledgers since the Medici family popularized it. And with that, we can go into a little bit of detail on Bitcoin itself, the first use case of blockchain.
Cool. So I'm only going to touch on this slightly, and the reason for this and that we're mentioning all this is because it will make sense of the layers later on. So Bitcoin is the most famous blockchain that we all know of. We've all seen this big orange symbol floating about. We've seen it in the news for good reasons, for bad reasons, and most recently because the biggest asset management firm in the world, called BlackRock, who has 9 trillion of assets under management, has decided that they want to sell Bitcoin to their customers and allow people to invest in it. Now, Bitcoin, as we know, the data is stored on these nodes, which are the computers that make up the network. But because the network is so big, it can take up to 10 minutes to add a new piece of information to the ledger, to the block, to the blockchain, which, depending on what you're doing, 10 minutes is a bit of a long time. 10 minutes for a financial transaction, it's not really that efficient for buying a can of Coke. It's not really that efficient for getting a bus, as we said. It's great for some things, but it's not ideal for other things. So let's go on to Ethereum. Now, Ethereum is the second most famous application, and Ethereum was created to solve some of the problems with Bitcoin, because you just couldn't really do that much with Bitcoin apart from use it as a store of value and occasionally use it for transactions. Now, Ethereum was created by a gentleman called Vitalik Buterin, and what Vitalik and his team did is they revolutionized this space by allowing people to build their own apps. So these apps are called dApps. Why are they called dApps? Because they're built on a decentralized network. So think of it again like the file storage. Imagine Dropbox, but split over multiple computers. This would be a decentralized app because it's no longer owned and controlled by just one computer or one company. It's split amongst the users. So this was revolutionized, and this gained a lot of attention because of things called smart contracts. And these smart contracts are very important to dApps because what they allow is they allow for the automation of pretty much anything. So any state transition, anything that can go from 1 to 0, that can go from A to B, that can go from left to right, can technically be coded and put into a smart contract. So you got to really think, what in the world has state transition? Literally everything. Your kettle going, or your thermostats, and your all these things that use technology eventually can have smart contracts in them, and automate absolutely everything. Now, when you think of AI, that's where you realize, wow, this automation stuff could get really, really wild. But what's the problem? The problem is that you have a thing called gas fees. Now, gas fees are what you pay to the Ethereum network to conduct a transaction. So remember what we said about transactions earlier on? Transactions are basically updating the chain, updating the ledger. Now, if you want to do that on the Ethereum network, you have to pay a small fee. But unfortunately, with Ethereum, this small fee, as more people start using the network, can get a bit silly and can get to around $40, $50. And in some cases, I've heard even $150. Do people want to pay $150 to send $10? No, that just doesn't make any sense. So this is, again, where do people want to pay $150 to get on a bus, to buy a can of Coke? No, they don't. So this is where, again, the problem is, and you need the scaling solutions. So let's go on to the next slide.
Just to tie a little bit back, as Michael was explaining, that Ethereum introduced state transitions to the blockchain. tie that back to what is a computer, right? A computer just holds states, which is the data, and then the state transitions, which is the transformations that that data can go through. So tying it back earlier a bit, but staying on the issue at hand, the scaling public-private.
So what we have with blockchains is we have two types of blockchains. We have a public one, which is what Bitcoin and Ethereum is, which means that absolutely everyone can access it, absolutely everyone can use it. However, the problem with this is the more people that use it, the slower it gets, because it's now got more computers that it needs to add information to complete the block, to complete the page of that ledger. Does that make sense? Hopefully it does. Now, the other thing is it's permissionless, and this is the exciting bit. This means that anyone can make their own chain or their own app or their own token on top of the Ethereum blockchain and on top of public blockchains. Now, a private blockchain, all of us in this group right now, we could make our own blockchain and make it our private blockchain. And that would mean that only the people that were in this call would ever have access to whatever files we wanted to upload to this blockchain. So it would mean we could make it that only the computers that are watching this webinar right now would be able to get access to the playback of this webinar, which, because there would only be 26 people that could ever view it, it would mean that it would be really fast to upload or download or watch, but you would need permission from one of the 26 people. Now, this isn't great for scalability, because what if we wanted to get millions of people to watch this? There would only be 26 people in the world that they could go to be able to watch this webinar, which isn't that efficient for scaling. It's great for keeping things private, and it's really fast, but it's not great for scalability. So let's go to the next slide. So this is one of my favorite slides. Now, this is something called Vitalik's trilemma. And this, again, deals with the issue of scaling and why layers are important. Because it's very difficult to have decentralization, loads of people on the network, on the blockchain, security in terms of keeping it private, and then scalability, again, loads of people using it, and it being fast transactions. Now, Vitalik is the gentleman just in the middle on the bottom. This gentleman here. The guy next to him is a guy called Gavin Wood, who created a blockchain called Polkadot. The guy above him is a gentleman called Charles Hoskinson, who created a blockchain called Cardano. And then there is a gentleman at the back, and he's the guy that created something called MetaMask for a company called Consensus. So that's important to know for the next slide. Okay, over to you, Musaddiq.
So, fine. So the layers of crypto, and this is what the focus of some of the focus of our talk is on, because this has become very popular in recent years, something that's arisen, and something that really shows you the versatility of blockchain. And actually, this is what makes blockchain complicated, because it's not just one blockchain that's doing one thing. We have lots of different blockchains being put to use for different purposes, but also the way those blockchains work are different, because now there's layers of blockchains. And as Michael was discussing, Vitalik with Ethereum has a problem, and that trilemma takes you through scaling. How many transactions can you put onto the chain? The security, how validated are the transactions, and then the decentralization. This one is, the more decentralized it is, the more computers are involved, the more distributed those computers are across the world, and usually the cheaper it is to get involved as a validator. So to start on the first layer of the blockchain, which is our general understanding, which is the layer 1 blockchains. It would be Bitcoin and Ethereum. These are layer 1 blockchains which act as the base layer of the blockchain. Here you just do your transactions as normal. And this is in Bitcoin, those transactions are sending or receiving money. On Ethereum, that's executing smart contracts. So putting forward state transitions, including sending money, or you might be lending, or you might be signing a contract. or it might be locking something up for a certain number of years. Now, as Michael said, Ethereum became very, very expensive to use because so many people are trying to use it at the same time. And everybody trying to use it, at millions and millions of people were trying to use it at the same time. And that led to the gas fees, which started at a few cents, becoming hundreds of dollars, which obviously became unsustainable. And now we ran into that scaling issue. And the way that scaling issue was solved was actually in 3 different directions. Crypto is an open space, it's permissionless, it prioritizes innovation, and therefore lots of people tried different ways to solve this issue. In trying to solve this issue, what emerged were these layers, or this is how, after people had their attempts, we started describing it as layers. So the first attempt, or the most basic attempt, the one that is easiest to understand, is on the layer 1 level. So on Ethereum's level, we had what are called alternative layer 1s. For example, Cardano, as mentioned, one of the competitors, one of the founders of Ethereum came out with Cardano. We've also had Solana. We've had Binance Smart Chain. These are all layer 1 blockchains, just like Ethereum, where you can post smart contracts and you have a network of computers that will verify the content of that smart contract and hold a record of it to make sure that it's always correct. Now, with Solana, for example, which has become very, very popular recently, it's an alternative layer 1 that instead of using the consensus, so this might get a little bit techie, but instead of using proof of stake, it uses proof of history combined with proof of stake. And this allowed it to process a lot more transactions than Ethereum can. Like Ethereum, I think, is about 15 transactions per second, and Solana is up to 50,000 transactions per second. So the scale is absolutely ridiculous. But tracing it back to the trilemma, some might argue that Solana is less decentralized and less secure. It's less decentralized because it's newer, so there's a lot fewer validators on the chain. So it has to sacrifice a bit of that decentralization. And the security, it's had a few fallout, it's had a few blackouts, it's had a few security issues where it's gone down that Ethereum hasn't faced. So you have that. And then you have a lot of different trade-offs along other blockchains like Cardano, Binance Smart Chain, Ethereum Classic, and these ones all make different trade-offs on that scaling, security, decentralization trilemma that Michael took us through on the last slide. So that's layer 1s. But as we mentioned, people dealt with this or tried to deal with this in different ways. We saw Gavin Wood. Gavin Wood was also a co-founder of Ethereum. And what he did was he built Polkadot. And Polkadot and Block is a layer 0 blockchain. So there are other layer 0 blockchains like Atom and AVAX. And they act as the base layer, as a base layer chain that allows you to launch application-specific blockchains. Right? So, for example, each of these blockchains use slightly different technologies, just like we've got different, from proof of stake, proof of work, proof of history, you've got parachains and side chains and different channel chains. So on DOT, for example, you've got Energy Web. Energy Web is a blockchain that's used for tracking energy and giving carbon rebates. They launched a blockchain using Polkadot, and that is specific to their use case, to their needs for counting or for keeping a ledger of different energy and different utilities. You've got lots of different, and so this is another way of solving that. You've got different players that want to build something and want blockchain to verify it, rather than launching a smart contract on Ethereum or on one of the alternative layer 1s, they launch using one of these layer 0s to enable an entirely new blockchain. And then the final way, and maybe this is maybe the most popular way, is layer 2s and even layer 3s. And what this does is, this allows you to stay within the Ethereum ecosystem. It's actually only relevant for Ethereum and slightly Bitcoin. Now, Bitcoin and Ethereum, they benefited from the network effects because they were the first ones to enable decentralized transactions or enable decentralized smart contracts. they have a lot of activity. They've got hundreds of billions, in Bitcoin's case, trillions, locked up in their ecosystems. And the way that this is locked up, because of certain agreements, because of certain commitments, because of long financial arrangements, people are reluctant often to move into a whole new ecosystem, whether that's a layer 0 or an alternative layer 1. And therefore, the scaling issue was instead solved through layer 2s. And layer 2s, so the layer 2s is, as we discussed, Ethereum, the cost of being on Ethereum directly or transacting on Ethereum directly is very, very high. So what layer 2s do is they roll up transactions into a bundle on the layer 2 chain, which is built on top of Ethereum actually as a smart contract itself. They roll up the transactions on that layer 2 chain, and then they post it onto Ethereum. So what you have is you still benefit from the security of Ethereum, but at a much lower cost, because now you've only got to pay for that bundle, that single transaction, which is the bundle, rather than all of the individual transactions that made up that are being done on the layer 2. And because of this, on layer 2s like Base and Optimism, you've got transactions are costing pennies, whereas on those same transactions on Ethereum directly cost, you know, tens, 20, hundreds of dollars. Now within layer 2s, it can get a little bit more complicated. We can go a step deeper because you have different types of layer 2s. You have the zero knowledge layer 2s, and you have the optimistic, you call them zero knowledge rollups and optimistic rollups. The most popular ones right now are optimistic rollups, and they're the ones that, you know, the Arbitrum, the Base, the Optimism, the ones that are very popular right now, and that's because they work. And what optimistic rollups do is they assume that all the transactions are correct, or everybody assumes that if it's on the optimistic rollup, if it's on that layer 2, then the transaction is correct. And they use fraud proofs. So the proof that they're posting, that when they post these transactions to the Ethereum, the layer 1, the main chain, that bundle of transactions, everybody assumes that it's correct unless somebody posts, you call it a fraud proof, but essentially unless somebody disputes it and says this isn't true. And then the layer 2 will go and check and make sure that will go and verify, okay, is it true or not? And they'll run the computation, you know, down on that single transaction.
I was going to say, can you use your parcel analogy?
Yeah. Okay. And then we've got the zero knowledge proofs. So what the zero knowledge proofs do is zero knowledge proofs, it provides more security because it checks every single transaction. It uses zero knowledge proofs, and zero knowledge proofs, a zero knowledge statement is essentially proving, and this is very complicated cryptography, a very advanced cryptography, where it proves that something exists without revealing the underlying information. And with zero knowledge proofs, ZK rollups, everything is verified in that way. So as Michael was saying, there's a good analogy to understand this. So optimistic proofs you can understand as optimistic deliveries. Zero knowledge proofs you understand as zero knowledge deliveries. An optimistic delivery, essentially, you're going to get a parcel, and that parcel is going to have a label that's going to explain what's inside the parcel. And everybody can see this label. So when you get your parcel, you're going to see the label, and you can check that the contents are correct. Most of the time, the person delivering it believes that the contents are correct. If it's not, you can raise a claim, you can raise a dispute. You have about a week to do it, and you can ask them to check. You can send it back and send your proof, and then you can ask them to check, and most likely they're going to see that you're correct, and they'll send you what they were meant to send you. That's an optimistic proof. In a zero knowledge proof, the label doesn't hold, the label doesn't say what's inside the package. So it preserves security better. Instead, it has an indicator. It indicates with an order number maybe what's inside that package without revealing to anybody else what's inside the package. And the key here is the zero knowledge proof. It runs as an analysis within the facility to verify with very, very high level of certainty that what it says is inside the package, for every single package, it is definitely inside that package. It uses Rather, it uses a specific, a precise weighing mechanism to make sure that what it says is on the label is actually inside the label. And then every single package it delivers is near enough guaranteed that this will have inside it what the label says it has inside it.
Let's go to the last slide.
Cool. And the last slide is, and that's I guess just to finish off here, like zero knowledge rollups sound like, why would you ever use an optimistic rollup when you have zero knowledge rollups available? And the reason is zero knowledge rollups, they have less delay period, they're more secure, but they're more expensive as well. And this is again that trilemma, right? That's like security, scaling, decentralization. And optimistic rollups have been around for a while and they actually work. So,
cool. So I'll wrap this up. So we have also got the layer 2s on Bitcoin. So on Bitcoin, we have similar. We have the Lightning Network, which allows for super fast transactions, basically by bundling the transactions together off chain and then going, oh yeah, all of these transactions are true. There we go. Let's send this batch through together all at once. And then we have other layers such as stacks. And what they're doing is they're allowing people to build apps and applications on Bitcoin through a very complicated mechanism. Cool. So let's go to questions.
Brilliant, thank you. But firstly, before we do that, I want to say thank you because seriously, great presentation, really walking people through the basics. And then definitely, I know people who are there next week will want to talk to you about some of that more detailed stuff. It's that balance, isn't it, of like the real basic, what is it? And then you actually, as you get into that conversation, you start getting into a bit more complication. So I think that gives people lots of things to come and talk to you about next week when they're in person. So that will be really great. So maybe we can take the